for the interval. So first thing we need to do is we need to determine our confidence interval formula. Let's look at it. So our confidence formula is x bar plus or minus our t of n minus 1, comma, the cumulative probability of 1 minus alpha over 2, multiplied by the standard error of x. So let's start with getting our x bar first. We're going to sum up all the nearest miles to the medical center. When you sum them up, you should get a value equal to 129.4. Divide by the 7, and you'll get our x bar is going to equal 18.4857. Now we have an x bar, we can determine our standard deviation from our data set here. When you do your standard deviation, you should get a standard deviation equal to 4.529. Now we have our x bar and standard deviation, and we know how many people are in our simple random sample, n equals 7. We can now fill in the appropriate values for our confidence interval. So we're going to have 18.4857 plus or minus our t of 7 minus 1, comma, 1 minus 0.01 over 2. Remember, if we have 99% confidence, our alpha here is 0.01. So put 0.01 in for our alpha in our equation, multiplied by our standard error of x, which is the standard deviation of 4.529, divided by the square root of n, which is 7. When we work all this out, you'll get 18.4857 plus or minus 3.707 times 1.7118. Then you should get 18.4857 plus or minus 6.3456, which then brings our confidence interval to be 12.1401, comma, 24.8313. How do we interpret this interval? This is where we state that we are 99% confident that the true mean distance to the nearest medical center lies within the interval 12.1401 to 24.8313. And that's how we do question 10. Moving on to question 11. A major university has recently reported instituting a new program aimed at reducing binge drinking behavior seen on campus residents after it was recently ranked as a top party school. After investigating a considerable amount of funding into a particular program, representatives for the university has been charged with the task of reporting the progress after 4 years. Suppose the following table represents the number of drinks per week prior to and after attending the program for a simple random sample. Students assume that a normal approximation is acceptable. So here we have our students, A, B, C, D, E, F, which is going to give you an N equaling 6. When you have your students here, you have them attending or how many drinks they had prior to an intervention and then following the intervention. So we know this is a pre-post test or a paired test, right? Because student A has to be paired with a prior to and after the intervention. You can't mix and match them. They are paired together. So we know we're going to be finding the delta of this group, which is going to be the difference between them, right? So let's read part A. Is there a significant amount of evidence to support the hypothesis that the university program is successful at reducing the number of drinks per week? Use an alpha level of 0.05. So let's set up our null hypothesis. Our null hypothesis is going to state H naught, that mu delta is going to equal 0, where our alternative hypothesis is going to be mu delta does not equal 0. So now we have to figure out, is their hypothesis correct in determining that the program has been successful? So for this, we will do our t-test. So our t-test equation is our x bar delta minus u delta over standard error of x. So in order to determine standard of x, we need our standard deviation, and we need an x bar of our delta. So the way we find this, once again, is you find the difference between prior and after 2 per the student. So student A, be 16 minus 4 gives you 12. 18 minus 5 gives you 13. 17 minus 3 gives you 14. And so on and so forth. Now that you have your new delta set, you can figure out the sum of your new delta set, which when you do that, you'll get 90 sum delta, and then your x bar delta is going to equal 15, and your standard deviation of delta is going to equal 2.3664. Having this information, we can then plug it into our formula and find out if there's a difference between if their intervention was successful in reducing the amount of drinks that the students had. When we placed it in, we get 15 minus 0, so our mu delta, divided by 2.3664 over the square root of 6, which is going to equal 15 over 0.9661. Kind of a really bad 15, huh? 15, and then that is going to equal 15.5263. So remember, that equals your t-test value. So 15.53 is your t-test value. Once again, I highly recommend when we're doing the equation, make sure you know what you're equaling to. I think a lot of times you'll get an answer and you'll say the answer is 15. No, the answer is 15, you know, as your t-value here. So we need to then take our t-value and go to the back of the book and find our p-value associated with it. Okay, so when you go to the back of your book in Table B, you'll first find your degrees of freedom for the equation, which your degrees of freedom for the equation is going to be n minus 1. So n minus 1 here is 5. So you go to degrees of freedom 5, and then you're going to try to find 15. Well, you're going to notice that you can't find 15 because it's way off the chart, right? Because we're saying it's like 15.5 standard deviation. So I mean, we don't know exactly the true p-value, but we do know that our p-value is going to be less than 0.001, because even at a t-value of 6, it's 0.001. If we want to, you know, since we are doing a two-sided test, we multiply this by 2. If we wanted to be more specific, we say p-value is going to be less than 0.002, which even at alpha level 0.01, there's going to be significance, but we're using alpha level 0.05, so there's significance that the intervention was successful. Okay, moving on to question number 12. So suppose a new company is interested in promoting their new diet managed program. The concept is similar to Weight Watchers and involves an overall reduction of daily calorie intake. Before making a more direct effort at promoting the success of their program, the company wants to get an idea of how effective their program is based on a simple random sample. Assume the following table represents results pre and post intervention. So right there, you should just know we're doing pre and post intervention of 9 individuals varying approximately to normal distribution. So we know our n is going to equal 9. Just based off this, so we know we're going to be calculating a delta automatically right away. Because we're doing a pre-post intervention match pair, so we're going to find our delta for this. And then just reading it, setting up the problem and reading it, the first part is what type of test design this, so we already know it's going to be pre-post. if I can write, or you can say paired sample. And then part 2 is carry out a paired t-test. Kind of already told you the answer. Investigating the effectiveness of the new weight loss intervention at reducing overall calorie intake. State your null and alternative hypothesis, and I want you to do a two-sided and interpret your p-value correctly. So here, we already know our, well, I don't know why it does that. Our null hypothesis is going to be a two-sided one, but our alternative hypothesis two-sided. Our null hypothesis is going to be null hypothesis of mu delta, right, because we know we're doing match pair, is equal to 0. And our alternative hypothesis is going to state mu delta does not equal 0. Remember, when we're doing our paired or matched, we're going to find our prior to and after, so pre-post, from participant 1, subtract them out, and you get 349, 775, 688, 505, 545, 324, 728, 96, and 487. When you add all these up, take the sum. So our sum delta here should equal 4,500. Our x bar delta should equal 500, and our standard deviation should be 218. Ran out of room, 5952. So now we can carry out our t-test. Remember, I think everyone kind of knows what the formula is now. So it's going to be 500 minus 0 over 218.5952. What is that? 5952. Divided by the square root of 9. So you're going to get 500 divided by 72.8651, which is going to equal 6.862. You go to the back of the book and you look up degrees of freedom 8. So you go to the back of the book for table C, go to degrees of freedom 8. Degrees of freedom 8, you'll see that our t-value of 6.826 is well beyond the 5.041, so we know our p-value is going to be less than 0.001, or we can say it's going to be less than 0.002 when we multiply by 2 because we're using a two-sided formula. The actual value, in case you're wondering, for this particular one, our p-value 100% equals 0.00012, but since we're using the table we just say that our p-value is going to be less than 0.001 times 2, or just 0.001, because when we're looking at a two-sided, it doesn't tell us the alpha here. Most of the time when we do an alpha level 0.05. Well, here it is. The 95% confidence interval here, so our alpha here is going to be 0.05. Don't know why it jumps on screen. If anyone knows, please let me know why it does that, so it doesn't keep happening. 0.05. Alright, so part 2 is we carried out two-sided hypothesis test, interpret our p-value. P-value is less than 0.05, even less than 0.01, so it's statistically significant. We are constructing 95% confidence interval now for this, and we're going to say our confidence interval is x bar delta plus or minus our t of n minus 1, comma 1 minus alpha over 2, which is cumulative probability, times standard error of x. Just going quickly, 500 plus minus 2.306 times 72.8651. You can get 500 plus or minus 168.027. You can get value 331.973, comma 6